going over standard 2.07 sequences and series. So, analyzing standard 2.07, if you go some vocabulary, a sequence is an ordered list of numbers. The recursive form of a sequence can be used to find the next term in a sequence, a n plus 1, given the current term in the sequence, a n. The explicit form of a sequence can be used to find any term in the sequence given the number term you want to find n. An arithmetic sequence adds the same number each time. The value you add from one term to the next is called the common difference. Hello. The common difference is equal to D. Should I get out of here in what, 15 minutes, 10 minutes?
Okay.
Is it?
Almost 9:30.
So just make sure I'm out of here by 9:30?
Yeah.
All right, we'll do. The common difference, which is equal to D. The recursive form of an arithmetic sequence is going to be AN is equal to AN minus 1 plus D. And what that means is that each term is equal to the previous term plus D. The explicit form given on our formula sheet is going to be AN is equal to A1 plus N minus 1 times D. Another explicit form is going to be AN is equal to ND plus A1 minus D. The explicit form looks like a linear function when simplified, distributing combined by terms. Now, after looking at arithmetic sequences, we'll look at geometric sequences. A geometric sequence multiplies the same number each time. The value multiplied from one term to the next is called the common ratio. The common ratio, TIO, is designated by R. Okay? So you have a common ratio, which is equal to R. In order to get R, you need to use the formula AN over AN minus 1. So each term divided by the previous term is equal to R. The recursive form of a geometric sequence is going to be AN is equal to AN minus 1 times R. So each term is equal to the previous term times your common ratio. The explicit form is going to be AN is equal to A1, the first term, times R, the common ratio, raised to the n minus 1 power. A series is the sum of the terms of the sequence. Sum of the terms of the sequence. Oh, an explicit form is going to look like an exponential function. because the variable is an exponent. A series is often represented by using sigma notation, where the bottom gives the first integer value of n, the top gives the last integer value of n. And this term is usually the explicit formula of the sequence. Explicit formula. So that's the explicit formula. All right. A series is operated using sigma. Yes. So a partial sum, usually is designated by Sn of a series, adds a finite number of terms. The formulas for arithmetic and geometric partial sums are on the formula sheet, but for arithmetic, you mean use the explicit formula to find an when calculating the partial sum. An infinite series, S, adds every single number in the sequence infinitely. Infinite series is said to converge if it sums to a finite value, so finite value, and diverge if it does not. Arithmetic series always diverge. Geometric series converge if R, your common ratio, the absolute value of it, is less than 1. All right, so now we're going to 2.07, multiple choice practice. Evaluate the series when from when n equals 4 to 8 of 3n minus 2. So this looks like a linear function. Because this is linear, this means this is arithmetic. And what we can do, and I'm going to minimize this, is that if you have this function, because you're only doing 4 terms here, because you're doing when n equals 4, 5, 6, 7, and 8. And in this case, it's probably faster just to add all the numbers up. But if you were to, do from 17 to 27, you have to replug in 17, call that a1, and then determine value. So let's actually do it so let's do it the fancy way, and this is just to do this so this could be harder, in case this becomes a harder question on your final exam. The arithmetic series, so an arithmetic partial sum, that's going to be Sn is equal to n over 2 plus a1 plus an. So here, n equals 4. That is going to be the first term that we're worried about. So that's going to be 3 times 4 minus 2. So it's going to be 12 minus 2, so that will be 10. So 10 will be equal to a1. And then this will be the first term we're worried about, the second term we're worried about, the third term we're worried about, the fourth term that we're worried about, and the fifth term we're worried about. So now, to find this term, this will be 3 times 8 minus 2. So 8 times 3 is 24, minus 2 is 22. So 22 is equal to an. So 10 is equal to a1, 22 is equal to an. Our number of terms is 1, 2, 3, 4, 5. So our partial sum is going to be equal to 5 over 2 times a1, 10, plus an, 22. So our partial sum should be equal to 2.5 times 32. So 2.5 times 32 is 80. And that is the correct answer. You could also just do, if you wanted to add it up, you could do 3 times 4 minus 2 plus 3 times 5 minus 2 plus 3 times 6 minus 2 plus 3 times 7 minus 2 plus 3 times 8 minus 2. That will also get you to 80. So that's problem 1. So you've seen how to brute force it and to use our series formula. And we have to do that if this becomes much, we have to use our series formula if the term becomes much larger. But notice it's 8 minus 4 plus 1. So if a convergent geometric series has an infinite sum of 4 and a common ratio of 0.3, what is the first term in the series? Okay, so looking at our formula sheet, a geometric sequence in series, S is equal to A1 over 1 minus R. So we have an infinite series formula. S is equal to A1 over 1 minus R. And it says the series has an infinite sum of 4, so S is equal to 4. The common ratio is equal to 0.3, so that's going to be equal to A1 over 1 minus 0.3. So that's going to be equal to 4 is equal to A1 over 0.7. And so what we do is you just divide each side by 4.7, so 4 divided by 0. Sorry, 4 multiplied by 0.7. So 4 times 0.7 will equal 2.8. So I multiply each side by 0.7. 0.7's cancel out, and 2.8 is equal to A1. So that's going to be answer choice D. Problem 3. The formula for a sequence given by AN is equal to 2AN minus 1 plus 3, and A1 is equal to 3. What is another formula that represents the sequence? So here, A1 is equal to 3. All right. A2, and this is one where it just makes sense to brute force. I think that's the best way to do it, is to look the pattern and plug it in. A2 is equal to 2 times the previous answer plus 3. So A2 is equal to 2 times A1, which is 6, plus 3, which is 9. So think that's 2 times 3, that 3 is coming from here, plus 3. That's going to be equal to 9. A3 would be equal to 2 times 9, which is 18, plus 3, which is 21. Okay, but with that being said, let's plug in our answer choices. Let's look at answer choice A. For answer choice A, let's look at when n equals 1. When n equals 1, you will have, or sorry, when n equals 2. When n equals 2, you will have 3 times 2 to the 1 minus 1, which is going to be equal to and so that's when, sorry, this is when n is equal to 2, right? So 3 times 2 to the 2 minus 1. So that's 3 to the times 2 squared, which is 4, minus 1 is 3, and then 3 times 3 is 9. So that's going to be equal to 9. So that's 3 times 2 squared minus 1. And so that, the second, when n is 2, the answer choice is 9. Now let's look at A when n is equal to 1. When n is equal to 1, that's going to be equal to 3 times 2 to the 1 minus 1. So 3 times 2 to the 1, which is 2, minus 1 is 1. So 3 times 1 is 3, which is the first term in the sequence. So A checks out, it plugs in, and the answer choices are coming out. So you just have to brute force this thing. You gotta recursively find the first term, the second term, and then plug in 1 and 2 for n and see if it works out. Luckily, A was the first answer choice and it made sense. We did take a little bit of time if we're finding the other ones. Luckily, with your calculator, you can plug things in really quickly. All right, which statement is true about the series 1 plus 2/5 plus 4/25 plus 8 over 25? So I want you to know something. The first term is 1 over 1. Then to get to 2/5, you multiply by 2, you multiply by 5. 4/25, once again, you multiply by 2, you multiply by 5. So you are multiplying, r is equal to 2/5. So this comes from your formula sheet. S is equal to A1 over 1 minus r. S is equal to A1 over 1 minus r. So the first term is 1. S is equal to the A1, which is 1. So that's A1, over 1 minus r is 2/5, because we multiply by 2/5 each time. 1 minus 2/5. So S is equal to 1 over 1 minus 2/5 is 3/5. 1 divided by 3/5 is going to be equal to 5/3. So the series converges to 5/3. That's problem 4. Problem 5. The recursive formula of a sequence is given by 6, 12, 30, 42. This is, let's look at the pattern here. Plus 6, plus 8, plus 8, plus 10, plus 12, and we have second order difference. So each time the term that you're adding is you're adding 2. So we don't have a formula for this, but what we can do is start plugging in values for n and seeing if the values come out. So let's start with answer choice A, plug in values for n, and see if it's going to work. So let's look at when, so remember when, let's analyze this for what 12. So when n equals 2, the output is 12. And remember when n equals 1, the output is 6. So let's start analyzing this. So let's analyze this at n equals 2. For the first equation, it'll be 2 plus the previous term plus 2 times the previous term, tn minus 1. If we're, in this case, when n is equal to 2, that's going to be 6 plus 1. That's equal to 16. This term is 12, so we can immediately cross out A. Let's look at B. T2, so would be equal to the previous term, which is 6, plus 1, times the current term number, which is 2, plus 2. That's equal to 28. So 12 is not equal to 28, so we can immediately cancel answer choice B. And this is just because you plug it. So in this case, we know that n2, we're checking for this, knowing that n equals 2 and tn minus 1 is equal to 6. And now we're checking. For answer choice C, you will have 2 times the previous term, which is going to be 6 plus 2 minus the current term number, which is 2 plus 2. This is equal to 12, so C is a possibility. And then D, you have the previous term, which is 6, plus 2 times the current term number, 2 plus 1. So these are both 12, so both C and D are now in the game. So now we need to look at term 3. So now we have to analyze when n equals 3, the output is 20, and so we have to plug in n for 3 and the previous term being 12 now. So now n equals 3 and tn minus 1 is equal to 12. So let's plug it in for C. 2 times the previous term, which is 12, plus 2 minus the current term, which is going to be 3, plus 2 is equal to 23. So when we do this check, this is equal to 23 when n equals 3. And that's not the case because the third term is 20 and not 23. So we can eliminate C, we eliminated A, B, C, and which means the answer choice is D. Hello, pre-calc students. For problem 6, how many terms of the sequence 1, 3, 3 squared, 3 cubed must be added together to get 3,208? So we're going to have to look at our formula sheet to find out the terms of a geometric sequence. And this is a geometric sequence because we see that for each term of the sequence we are multiplying by 3. 1 times 3 is 3. 3 times 3 is 3 squared. 3 squared times 3 is 3 cubed. So we have a common ratio of 3, and we're multiplying by 3 each time. Looking at our formula sheet, our equation is S is equal to A1 over 1 minus R, where R is less than, absolute value of R is less than 1. So we have S is equal to A1 over 1 minus R. A1 is equal to 1, and here R is equal to 3. Alright, so now we need to plug in our values. The series adds up to 3,280, so that's equal to S. A1 is 1 and R is 3. So S is going to be equal to I'm sorry, this is A1 times 1 minus R to the N.
I need to leave Tucker upstairs because I'm going to have like little screws everywhere.
Over 1 minus R. And so S is going to be equal to 3,280. So 3,280 is going to be equal to A1, 1 times 1 minus R to the N. And here, R is 3. 1 minus 3 to the N all over 1 minus 3. So that means that divide at 3,280 is equal to 1 minus 3 to the n over negative 2. Multiply each side by negative 2. So I take 3,280 and I multiply it by negative 2. So I end up getting the equation negative 6,560 is equal to 1 minus 3 to the n. Subtract each side by 1. You get the equation negative 6,561 is equal to negative 3 to the n, which sets up the equation 6,561 is equal to 3 to the n. So if both sides are negative, you can cancel out the negative, divide each side by negative 1. And then we can take a logarithm. To get the n out of the exponent, we can say that the log base 3 of 6,561 is equal to n. So we can take the log of 6,561 divided by the log of 3. And that answer is going to be 8. So evaluate the logarithm with your calculator and you find that n will be equal to 8. The first term in an infinite geometric sequence is 2. The sum of the sequence is 6. What is the common ratio of the sequence? So we have the first term of an infinite geometric sequence, and an infinite geometric sequence is going to have the form of the equation S is equal to A1 over 1 minus R. S is equal to A1 over 1 minus R. Here, the sum is 6, so S is equal to 6. The first term is equal to 2 over 1 minus R. We need to solve for R. So multiply each side by 1 minus R, you will get 6 minus 6R is equal to 2. Subtract each side by 6, and you have negative 6R is equal to negative 4, and R is equal to negative 4 over negative 6, which will simplify into R is equal to, negatives cancel out, 2/3. So the answer here is 2/3. That's problem 7. Moving on, problem 8. The first 15 terms of an arithmetic sequence of the sum to 975. If A1 is equal to 16, what is the value of A20? And this question has a little bit of typo, so first we're going to find A20, and then we're going to find S20. So 975 is going to be equal to the first 15 terms, 15 over 2 times A1, which is going to be 16, plus A15, which we need to find. So remember, this is in the formula Sn is equal to n over 2 times A1 plus An. So what we have to do is find A15. So our first step is to take 975, divide it by 15 over 2. So 975 divided by 15 divided by 2, 7.5, is 130, which is equal to 16 plus A15, and then subtract 16 from each side, and you will end up with 114. So 114 is equal to A sub 15. From A sub 15, we need to find A sub 20. So we need to find our common difference. So if 114 is equal to A sub 15, and a1 is equal to 16, we can find our common difference. D is going to be equal to a15 minus a1 over 15 minus 1. So that's going to be ultimately equal to 114 minus 16 over 14. So we'd use 114 minus 16 divided by 14. The answer is 7, so D is equal to 7. And now at that point we can find A20. So A20 is going to be equal to A1 plus 20 minus 1 times 7. So, and A1 here is going to be equal to 16. D is equal to 7. So we're using our formula from our formula sheet. AN is equal to A1 plus N minus 1D. And in this case, A20, we're using the 20th term of the sequence. Our first term is 16. Our common difference is 7. And then it's the 20th term minus 1. So A20 is going to be 16 plus 19 times 7. So A20 is going to be equal to 149. And the answer choices are a little bit flawed because it's going the possible answer choices for S20. So finding the sum of the first 20 terms, that's going to be equal to 20 over 2 times A1, which is 16, plus AN, which is going to be A20, which is going to be 149. So 149 plus 16 times 20 over 2, which is 10. And S20 is going to be equal to 1650. So make sure that loads, and then that's problem 8. Problem 9. Which statement is true about the series shown below? Pi plus 3 pi over 4 plus 9 pi over 16 plus 27 pi over 64. So we need to figure out what the common ratio is. And we need to find out the common ratio, we need to divide one term by the previous term. So to find R, let's divide a term by the previous term. So let's divide, you do 9 pi over 16 divided by 3 pi over 4, which is going to be equal to 9 pi over 16 times 4 over 3 pi, and the pi's will cancel out, and you will just get 9 times 4 is 36, and 16 times 3 is 32 plus 16 is 48, so 36 divided over 48. Let's have the calculator simplify that for us just to make sure that we're sure that, so that's 0.75, that's going to be 3/4. So R, so we need to find R, and R is going to be equal to 3/4. Now we use our geometric series formula. Looks like we've crashed here, but nevertheless, our geometric series is going to be S is going to be equal to A1 over 1 minus R. So S is equal to A1 over 1 minus R. So S is going to be equal to pi over 1 minus 3/4, which is equal to pi divided by 1/4. And pi divided by 1/4 is the same thing as pi times 4. So the series equals 4 pi when you add up infinitely. So the series is going to converge to 4 pi. So pi divided by 1/4 becomes 4 pi. And that's your answer. Karen recursively generated a sequence of 5 possible integers by starting with a positive integer a1 and applying the recursive formula an is equal to an minus 1 plus 3n minus 1 to generate an for n equals 2, 3, 4, and 5. The value of a5 was 407. What was the value of Karen's initial starting term, a1? So what this recursive formula is saying is that each term is equal to the previous term plus 3 times the current term minus 1. So let's start from a5 and go backwards. a5, which is equal to 407. So 407 is equal to a4, the previous term, plus the current term number, 3 times 5, minus 1. So 407 minus, and so by the way, that's going to be 407 is equal to a4, 15 minus 1 is 14, so a4 plus 14, 407 minus 14, 393. So 393 is equal to a4. Do it again for a3. 393 is equal to a3 plus 3 times 4 minus 1. So it's going to be 12 minus 1. So it's going to be plus 11. So 393 minus 11 393 minus 11. So a3 is going to be equal to 382. All right. Now 382 is going to be equal to a2 plus 3 times 3 minus 1. So 382 minus 8, hopefully you're seeing a pattern here. 374 is equal to a2. So it's equal to a2. And a2 is going to be equal to a1 plus 3 times 2 minus 1. So that's going to be subtracting 6 now. 3 times 2 is 6, minus 1 is 5. Sorry, subtracting 5 now. 3 times 2 is 6, minus 1 is 5. So 374 minus 5 is 369. So 369 is equal to a1, and that is our answer choice. So that's 10. Moving on to 11. A sequence's numbers is defined as a1 equals 7, a2 equals the cube root of a1 plus 1, a3 the cube root of a2 plus 1, and so on. What is the value of a5 to the nearest hundredth? So each term is the cube root of the previous term plus 1. So we're going to have to plug this into our calculator. A2 is going to be the cube root of 7, so I'm going to do 7 raised to the 1/3 power and then add 1. So that's A2. So the work here is calculator 7, to use the cube root of 7 plus 1, which is going to be equal to answer, and then you're going to repeat the process. take the we're going to take 2.91, take the cube root of 2.91, add 1. So that's going to be the third term. Take the cube root of 2.42, add 1, that's A4. Take the cube root of 2.34, add 1, and so that's A5, and that's pretty much 2.33. So repeat the process. A5 is equal to 2.33. So watch what's going on in the calculator here. Number 12. Mr. Smith has recently retired. He will rely on his savings to supplement Social Security. He has an account in which the balance was $25,000 in 2018. When he retired, the account earns interest at a rate of 4.8% annual interest, and interest is compounded annually. Mr. Smith will withdraw $9,000 from the account each year, which correctly gives a recursive formula to represent this situation. So he has an account where the balance was $25,000. All right. It's going to get 4.8 annually interest, and he withdraws $9,000 from the account each year. So if you think about it, each time you were taking, for the value of the account in each year, you're taking the value of the account in the previous year and multiplying and having an increase of 4.8%. And an increase of 4.8% means you're multiplying by 1.048. That's an increase. That's growing 4.8%. After growing 4.8%, this person subtracts $9,000 from the account. So he subtracts 9,000. In that case, we've set up the equation, and the answer choice is A. So this is just going to require you to think about what the recursive function is going to be. 13. There are 15 rows of seats on a concert hall with 25 seats in the first row, 27 seats in the second row, 9 seats in the third row, and so on. If the concert hall sells out and charges $12 per ticket, how much money will they have made? 7,020. All right, let's see how we get there. There are 15 rows. N is equal to 15. A1, the first row, is equal to 25. And each additional row, you add 2. D is equal to 2. Okay? So we need to first find A15. A15 is going to be equal to AN is equal to A1 plus N minus 1 times D. So A15 is going to be equal to 25 plus 15 minus 1, which is going to be 14, times 2. So 25 plus 14 times 2 means that the 15th row has 53 seats. And if you think about it, that's going to be, yeah. And so now we need to find out how many people, total people, are in the first 15 rows. So S15 is going to be equal to 15 over 2 times A1, which is 25, plus A15, which is 53. So remember, Sn is equal to n over 2, 15 total seats, times 25, which is A1, plus 53, which is the last term in the sequence. Okay, so we find S15. So we have 7.5 times 25 times 53. I'm recording. Is it urgent? Okay.
Yeah, I'm coming.
So S15 is equal to 15 over 2 times 25 plus 53. That case, S15 is going to be equal to 9,000. Oh, big mistake here. 25 plus 53. So you do 7.5 times, make sure you enter things in your calculator right, 25 plus 53. So there are 585 total seats in the concert hall. And if the concert hall sells out 585 times $12, so 585 seats times $12 a seat is going to be equal to 7,020. So the answer choice is C, 7,020. 14. Write an explicit equation for the arithmetic sequence with A12 equal to 63 and A19 equal to 7. AN is equal to 151 minus 8 times n minus 1. Alright, let's figure out how we get there. An explicit equation is going to be figuring out, we're going to get out some specific things. We need to figure out AN is equal to A1 times, or A1 plus n minus 1 times D. Google Chrome's messed up here. Alright, so AN is equal to A1 plus n minus 1 times D. And so what we need to do is find our common difference and then find A1. Okay? So we need to find our common difference. So to find our common difference, we can find A12, we'll find between A12 and A19. So we know that A19 minus A12 over 19 minus 12 is equal to D. And so here this would be equal, so D is equal to 7 minus 63 over 19 minus 12. And 19 minus 12 is 7. So we have 7 minus 63 over 7. So we use 7 minus 63 divided by 7. And we get our D is equal to negative 8. So if A12 is equal to 63, A11 is equal to 55, A10 is, wait. If we subtract 8 going forward, we are adding 8 going backwards. So if A12 is 63, A11 is 71, A10 is 79, A9 is 87, A8 is 95, A7 is 103, A6 is 111, A5 is 119, A4 is 127, A3 is 135, A2 is 143, and A1 is 151. So we know that A12 to A11 is going to be 63 plus 8 moving backwards. If it's minus 8 moving forward, it's plus 8 moving backwards. So that's going to be 60. So that's going to be 71. We do the same process all the way up into A1, which is equal to 151. And now that you have A1, we can write the explicit formula. AN is equal to A1 151 plus negative 8, or just minus 8 times n minus 1. So that's what is AN equal to. That's answer choice A. Another way, you could just say 151 plus n minus 1 times negative 8. That would also work, but hopefully you can see that this is the explicit form. Another way to do this is just to plug 12 into all of these answer choices and to see which one spits out 63. That would also work. Suppose that A1 equals 7, and AN is equal to 5 times AN minus 1, when n is greater than 1. Which answer choice gives an explicit formula for the sequence? AN is equal to 7 times 5 to the n minus 1. Let's see how we get there. So, remember, the explicit form of a sequence is going to be, this is going to be geometric. And this is geometric because we are multiplying. Because each term is equal to 5 times the previous term, multiplying. Alright, so the formula for a geometric sequence is going to be AN is going to be equal to A1 times R to the n minus 1. Here I can see each term is the previous term times 5. Just by analyzing the recursive formula, I can say that R is equal to 5. I can see here that A1 is equal to 7. So AN is equal to A1, 7 times 5 to the n minus 1. Alright, that's the entire video. Good luck on your final exam.